Autoscaling, I'm gonna start like, who does give a shit about scaling? So, who does not give a shit about scaling? Okay, so you have probably a deep pocket, a lot of money to spend. Okay. I asked this because my first slide is very marketing, and I hate this, so I rather ask it, who does give a shit or not? All right. Now, I like this slide because it's pretty much talking about the 3 dimensions of scaling. I'll try to go over about those 3 dimensions today and do 2 demos. So first, cluster scaling, nodes coming back, size of the nodes, etc. We'll have slides on cluster autoscaling, and we have slides on Karpenter. I did a talk with Karpenter with Lucas back in February. I did as well in a webinar, and so on, and I'm a big fan of both, cluster autoscaling and Karpenter. Then we're gonna, actually this is gonna be the last. We're gonna talk about horizontal pod scaling, when you create replicas, and vertical pod scaling. So the 3 dimensions. So let's first talk about horizontal pod scaling because arguably it's the most common. It's built in on Kubernetes. You don't have much to do to have HPA than installing the metric server. We're gonna have a quick open parenthesis about metric server, but basically HPA, you create an object called HPA. It queries the metrics and then increase the number of replicas of the deployment. The deployment has the number of replicas. It's a spec, it's a field under the spec. So HPA, basically when you create an HPA object, manages that field as an external manager. Who does know about server-side apply and external manager fields? I'm gonna go over if time permits. But basically, Kubernetes object, it's a long-ass object with a lot of properties. On the deployment, many lines, but HPA only cares about the number of replicas, so it will be the manager of that little field. So if you do kubectl -- show managed fields, you're gonna come a long-ass output. And that's what it tells who manages what field inside of the object. The best way is really learning by doing. So you're gonna start from scratch an HPA. And I do have my labs here. It's on the Stormforge webinars. We have a bunch of webinars. I just created in the past 2 days the Autoscaling webinar. So the first thing we're gonna do is set up the metric server. Who does know what's metric server? What is the purpose of the metric server? It's right here. You just have to read. The only thing the metric server does, it feeds metrics for the autoscaler. Do not mix, do not confound with metric server, with kubestate metric, with Prometheus, etc. Metric server is almost an internal component of the Kubernetes. Now, I do have a kind here. It's completely empty kind, does not come with the metric server, but it's very easy to install. And your Kubernetes of choice probably comes with the metric server. And because it's a kind, I need to run it in insecure mode. So why I'm taking this time to explain this? Why? Because it shows some stuff that many people do not know or care to know. Have you ever run kubectl top pods? That's where, my metrics API are not available.
Takes a while sometimes.
Who does know this command line, the obscure command line? kubectl get API service. When you install the metric server, it registers itself as an API service. This is a kind API service. So what it does behind the scenes, it tells the kube API, hey, this v1 beta 1 matrix, this path for the API points to this pod. This deployment. So that's the kubectl get API service. Okay, there we go. The moment that this is up, you see here, when it's still starting, it calls false. I don't know what's going on, but now it's true. Now my kubectl top is working. So the only purpose in life for the kubectl, the metric server, is scrape data from the C advisor, register itself on the kubectl, the kube API. I'm gonna take over this RESTful path endpoint, and that's HPA, VPA, and kubectl top starts to work. Right, open parenthesis. Very well. Now what I'm gonna do, that's the lab 0, by the way, just to have that the plumbing. I will go ahead and kubectl apply -k. Who doesn't know -k? Customize, very good. Kubectl apply -k in my directory. Basically what I'm gonna do, I'm gonna create 3 deployments. And bear with me right here. I have one deployment, they're exactly the same, but one has no requests, no limits. Another one has requests with 500 millicores, no limits. I don't care about limits. I live in the wild, no limits. And small requests, I put just 50 millicores. So I have those 3 pods running on this namespace, CPU demo, happy. I'm gonna go ahead and I'll create the HPA. There's this command line called kubectl scale, deployment, deployment. You're gonna do the magic for me. Okay, yeah, HPA. So far so good. This is CKA stuff, right? That's, CPU demo. Speaking at still unknown. Oh, all of a sudden 2 showed up as 0, and now it's 1 now. Why this one is unknown? Is that my metric server down? It's not up yet. Is a CKA question.
No request.
Who said that? There we go, Bobby. If you don't have requests, HPA cannot help you. So the number 1, another reason that you need requests, and I gotta give a spoiler. My company does request calculation for a living, so I'm gonna be all over you guys setting requests. I don't care how, but you have to set requests. So first, lessons learned, no requests, no HPA. Now, what I'm gonna do, oh, by the way, if I do describe on that guy, it will tell what's going on. Like, hey, I don't have requests, and I can do the calculation for you. Because the HPA, the way they create this HPA, I gave some parameters here. I'm gonna scale with CPU. If it's more than 50%, then it's scale with the minimum 1, maximum 5. And where this 50% came, mostly out of my ass. That's how people do. Like, I don't know. Right? That's life. Who never? So I put 50, and then 50 of what?
Set CPU, wherever.
of the request. Right, very good. So this particular workload, it is a load scale, forgot the name of it. Basically, I can tell to use more CPU. So if I do kubectl top pod, those are my three guys. So they're using very little. What I'm gonna do, I'm gonna tell the second one, this guy, to use 550 millicores for 1 hour. Remember, the request is 500. So what we expect here? So it's gonna consume 550 millicores for 1 hour. If I do this again, HPA CPU demo, it takes some time to start to run. Let me take a look. HPA, I should set my CPU demo, sorry. Come on, buddy. Let's go. It's a Google app, you know. It's taking sweet time. Right. Anyways, you gotta believe me, or we're gonna wait until like 9 o'clock, but we're gonna get kicked out. This is gonna go 450, and 450 of 500 is 90%. So HPA gonna go double, and that's gonna bring down from 90% to 45%, which is less than 50, and life is fine. That's a very simple demo, the simplest demo ever. And let me send the curl command again. I know what's going on. I know what's going on. I just have to kill my other background jobs. Okay. This now. Yes, we do the curl again. Oops, it's up top. It's gonna take some time. The other demo, with the small one, that's the most interesting one. And that's why I'm gonna explain you have to be very careful with HPA with CPU. The other demo only have 50 millicores as a request. And I send another command of 550 millicores. So what HPA gonna think? I have 900% of utilization. That's wild, 900%. And then we will scale up to 5 replicas to bring down, even though 5 replicas is gonna show 180%. But when I do kubectl top, I have 5 replicas. Only one has all the CPU, the other ones are doing nothing. So that means that now it's doing the other one. Yeah, 90%. It will basically bring down to 50. Let me see if I can do the other small one. Do the small one. This. And I have everything here on my Git repo.
We need a cane for it.
Thank you. Okay. I forgot how to do kubectl pod all the time. It's not W. But it will show all the replicas. So basically, you gotta be careful doing HPA on CPU only. And that brings us that's how we scale CPU. The desired replicas, it's a calculation of the target utilization, current utilization. Current utilization is the CPU time that your app is doing is based on the requests. You have to set the request and set something meaningful. If I set my request for 50 millicores and it can take 450 millicores using it, because I don't have limits, that's gonna be 900%. The point being is it will go up and down, up and down, up and down, and then use a different metric to do a scale. That brings the conversation to KEDA, and I do have a demo for it. If you want to do me a favor today, I'll put this somewhere that you can download this. There is a link for this talk to KubeCon Detroit 2022 from one of our customers, Acquia, and another guy from AWS. They explained beautifully. Well, they had a little time, but they explained beautifully what request translates in time of CPU, and then how this metric is very misleading. And that came from that talk. That was using CPU as a scaler, and all of a sudden using an external metric. Look at this. Look at the churn, how different. Let's talk about KEDA. Why KEDA exists. So first of all, KEDA stands for Kubernetes Event-Driven Autoscaling. The HPA you can put external metrics on it. You can do it, awesome. But KEDA does this much easier for you. It's a CNCF project, and it has more than 50 built-in scalers like this. This is just a screenshot limblessly from the website I put here. We're gonna do a demo on RabbitMQ, which is the same demo that comes from KEDA. Cool things about it can scale to 0. HPA does not scale to 0. Think about the money. Everybody who cares about scale, except for you, I'm just kidding, dude.
I'll tell you the numbers after the meeting, so you will understand that I'm taking care of some of the stuff.
Okay.
A little bit more serious.
No.
I'll share the numbers.
Okay.
You'll be excited. Trust me.
Having scale to 0 is a big deal, and let's do a quick demo right now. Very quick. You have probably 5 minutes. You know what? I'm just gonna walk over the demo. Right, you install demo, we install KEDA. Check if KEDA is running. KEDA, the heart of KEDA is something called scale object. That's gonna heavy lift the whole thing for you. In this demo, basically, we're gonna scale based on RabbitMQ. It's one of the 50 scalers type right here. Type RabbitMQ. And this one, I'm gonna scale up to 30 replicas. And I'm gonna check the RabbitMQ queue for 5 seconds. I'm gonna look for the queue name hello, and if it's 5 in the queue, scale up. Here, I install RabbitMQ very quickly. Now I have RabbitMQ running. Then I install this RabbitMQ consumer, which is 0 replicas. This guy does have, when I do this apply, this guy does have the scale object exactly like I showed here. And then when I start another workload just to pump messages into that hello queue, in that case I put 500, that triggers the scale, and then all of a sudden now I have 1, and then realize the queue is long, it's deep, then go to 4, then 8.16.30. And when you install KEDA, it registered again the same API service, v1 beta 1 external metrics. So the Kube API has a placeholder for external metrics. So when you install KEDA, it points to the KEDA operator metrics. So you can only have one KEDA running per cluster. That's very important. And apparently Datadog as well register with that, so you cannot have Datadog and KEDA running at the same time. So I'm a big fan of KEDA, and is a CNCF project, and has all the autoscalers, the trigger points, etc. So that's horizontal autoscaling. Cluster autoscaling, have cluster autoscaler from CNCF since forever, 6. Big fan. How cluster scale up is easy, scale down, that's the problem, right? So basically you have some tunings on the cluster scaling, like utilization threshold, so the cluster scaling start to drain and remove nodes. Then we have Karpenter. That's for more AWS. I'm a big fan of Karpenter. Basically has all these options. It's much faster to instantiate nodes. Very fast, like 30, 40 seconds. And I'm a big fan of automatic consolidations, almost like a defrag. It picks. And another piece I'm very fan of, you define as many types of instances you want, different sizes, spots, demand, or C-type, etc. You can give weights, and it's called application autoscaling because you can delegate to business units. Talking about multi-tenant, you can delegate to business units how to handle their own types of nodes and autoscaling types. Okay, you have 6 minutes. Now, vertical autoscaling, VPA, and that's pretty much what I have not a problem, but that's what about requests that I talk about. VPA is pretty much setting up the size of your pods. So this data from Datadog says that 50% of every single pod out there is over provisioned. It's normal, it's part of life, right? Like, in doubt, you're always gonna shoot up. So in the typical, what we see from StormForge that they work for, that's the journey. You don't set anything, something happens, or it's super expensive, or have performance problem, then you pick one number, you disseminate that number around, and you start to continue to have problems. Then you have to start to look each workload individually, and in our experience, it does not escape. I used to be engineer manager for Citigroup for 6 years, and my life was pretty much a hell. Trying to manage all the workloads, and the most important applications got my attention. The other ones, I'm sorry, you have to do your homework to tell me how much you need. VPA is part of the autoscaling project, the same as HPA, and I will do this slideshow very quick. That's how our company explained the VPA works. Basically, when you install VPA, you have the metric server. We spoke about metric server. They have all these components here: recommender, admission controller, updater. The recommender looks at the metric server and then look at the deployment and recommends a new value. Then updater go ahead, delete those pods that they do not have the same value that recommend does. So there is eviction going on. Then the admission controller mutates the requests of each pod. Now, I'm sorry I put this together today. Why VPA is not popular? Who does use VPA here? Exactly. First of all, if you use HPA, you cannot use VPA.
Yes.
That's almost like a deal breaker. Not enabled by default. If you want to enable, it's being recorded. So I don't want to have any hate from the VPA folks, but you got to put some way better to install instead of going to the hack. You have to git clone and go to the hack directory and do a VPA up script. Put at least a Helm chart. Help a brother out. The calculation of VPA's math, of course, percentiles, histograms, weights is not a machine learning. So then you leave something on the table. If you use the metric server, usually doesn't have the historical. I have 2 minutes. Then you can plug on Prometheus. Very good. But it starts to get a little, another moving part. Not many people like eviction. Not people like admission controllers. And if you want to set up VPA different parameters, I want to be a little bit more aggressive or less aggressive, you have to install multiple controllers, so you cannot configure per workload. Very well. Plug time. My company does this for a living. We think about enterprise VPA. It integrates with HPA, with KEDA, and Karpenter. We $3 per CPU. We see all the time people saving 40, 50% in the first week of all the clusters. And as an engineer manager, I really like to solve the workloads that silently starving for requests. And that's what we do as well. Because in the moment that you give exactly requests and limits, that's what you got. For free, you can use this QR code. If you sign in, no credit card. If you use this QR code, the marketing told me that they will give swag. I don't know exactly what it is, but it's gonna be attached to this presentation. And my friends, I did Autoscaling in 20.